Given f of x comma y equals the square root of the quantity x squared minus y squared, which of the following regions are in the domain of f of x comma y? Where the domain of a function of two variables is a set of all possible inputs or a set of all possible ordered pairs. So in this case, it'd be all possible values of x and y. But because we have this square root here, and f of x comma y must be a real number, we know the radicand, or x squared minus y squared, can't be negative, and therefore to help us find the domain, we'll solve the inequality x squared minus y squared must be greater than or equal to 0. So let's work on solving this for y. Let's first add y squared to both sides, which would give us x squared is greater than or equal to y squared. If we prefer to have the y squared on the left, we can switch this around. This is equivalent to y squared is less than or equal to x squared. Notice in both cases, the inequality symbol is pointing toward the y squared. And now here's where it gets a little bit tricky. We want y here, not y squared, but notice in both cases, if we're squaring x and squaring y, the result would be positive. So when we take the square root of both sides here, the square root of y squared would be the absolute value of y to assure that this result is positive. And the same thing on the right. The square root of x squared is equal to the absolute value of x. So to determine the domain of f of x comma y, we want to graph this inequality on the coordinate plane. To do this, though, we'll break this up into two separate inequalities based upon the sign of y. So for example, if y is greater than or equal to 0, we don't need the absolute value around y, and therefore we can say that when y is greater than or equal to 0, y will always be less than or equal to the absolute value of x. But if y is negative or less than 0, this result still has to be positive. So if y is negative and we want to drop the absolute value, we'd have to take the opposite of y. So we could say negative y is less than or equal to the absolute value of x. So if we solve this for y, we'd multiply by negative 1. When we do this, though, we have to reverse the inequality symbol. This would be equivalent to y is greater than or equal to negative absolute value of x. And therefore, to find the domain of f of x comma y, we want to graph this inequality and this inequality and determine when they're both true. So to graph y is less than or equal to the absolute value of x, we should recognize that this v shape here would be the absolute value of x. So if we want to graph y is less than or equal to the absolute value of x, we would actually shade down. But we also want to know when y is greater than or equal to negative absolute value of x. Well, this v shape here that opens down would be the graph of y equals negative absolute value of x. So to shade when y is greater than or equal to negative absolute value of x, we'd actually shade up. So we can see these inequalities are both true in this region and in this region. And therefore the domain of f of x comma y would be in the regions B and D. Now let's graph this surface in 3D and look down on the xy plane to verify this domain. Here's the graph of our surface. The software is having a little difficult time graphing the surface here near the xy plane, but we should be able to tell it's half a cone, where this axis here is the positive x-axis and this axis here would be the positive y-axis. So let's rotate this so that the positive x-axis points toward the right and the positive y-axis points upward. Now that we have this rotated, let's look down on the xy plane to verify our domain. So if we pause here, this does verify our domain is when y is less than or equal to the absolute value of x, and when y is greater than or equal to a negative absolute value of x, or this region and this region in the xy plane. I hope you found this helpful.